So today's video is going to cover the introduction to functions, and for today there is no student audience right now, so we're just going to go through the notes fairly quickly because a lot of it is fairly self-explanatory. So by all means pause the video where need be to write down any notes you have, and that being said, here we go. We're talking about the introduction to functions, and a function is basically a relationship between an input value and an output value. So, for example, if we were to look at an ordered pair, this is technically a function. The input value would be 1, and the output value would be 2. Something that you should know from last year's math class would have been that the input value is associated with the variable x, and then the output value is associated with the variable y. All of your ordered pairs are x, y coordinates. So very important thing to remember, your input value is always the x variable, your output value is your y variable. So this set of ordered pairs is showing you a function. When you put in 1, you get 2, when you put in 3, you get 4, so on and so forth. There are a couple other ways that you can represent functions, and here they are. We have a mapping diagram, which is essentially showing you the similar idea. On the left-hand side of the mapping diagram, we have all of the x values. As you can see, 1, 3, 5, 7, and 9 are all in the x-coordinate position, and they appear in the left part of the mapping diagram. And then over here on the right, we have all the y values. 2, 4, 6, 8, 10. Those go in the right part of the mapping diagram. And then all the arrows in between are just showing you that 1 points to 2, 3 points to 4, just like we have up here with the ordered pairs. Now over here with the graph, it's still essentially the same idea, only we are now plotting points on the coordinate plane. So in this particular case, the x-axis, something else that should be known from last year's math class, is located on the horizontal line, and then the y-axis would be the vertical line. When you plot your points, they would go up in a ascending fashion just like this, but in all three of these cases, we are just representing a function, what it basically is. Now right down here, we're going to talk about a couple really important vocabulary words that definitely will appear on the end of course exam. The first word being the domain. The domain of a function is every possible input value that could be used in a function. It's basically referring to just the x values, but this definition is very broad because the idea of a domain is that anything that could be inputted into the function would be included in this set. Generally though, it's just referring to the x values, and that would be enough to do what we're doing in this video. Likewise, what goes hand in hand with the domain is something called the range. If the domain represents all the input values, or the x values, the range is going to involve all the output values. It's every feasible output result that could happen in a function, basically all of the y values. So the domain is your x value, the range, all of your y values. Now moving right along, let's look at an example that kind of highlights this point. Bob's Burgers charged $5 per burger. Represent the function for buying 1, 2, or 3 burgers as an ordered pair, a mapping diagram, and a graph. So this is just covering what we were doing just right up above here. So this would be a time to perhaps pause the video if you need to practice this, or simply keep going if you just want to see how everything is worked out. The first thing we would create is the set of ordered pairs. Basically, let me just get and that. So if Bob's Burgers is charging $5 per burger, well that means one burger is going to cost $5. That would create the ordered pair 1, 5. If you are going to purchase 2 burgers, Well, if it's $5 per burger, then you are just doing 5 times 2, which is going to give you 10. So that means 2 comma 10 would be the second coordinate point. And then likewise, if you're going to order 3 burgers, 3 times 5 is going to be 15, and that would be the last order pair, 3 comma 15. In order to make the mapping diagram, all of the domain values, all of the x values would go on the left-hand side of the mapping diagram. Because remember, just like it says up above, the domain is every possible input value that could be used in the function. It's just the x values. What we had in this situation is that our input values were 1, 2, and 3. So that means when we create the mapping diagram, you would want 1, 2, and 3 to be on the left, and then the corresponding amounts that you would spend on getting those burgers would be 5, 10, and 15. So this would be the mapping diagram. Lastly, we have the graph, and the graph is simply just showing you the ordered pairs of 1 comma 5, 2 comma 10, and 3, 15 on the coordinate plane. But as you can see, I just counted by 5s along the y-axis. And then 1, 2, and 3 down here on the x-axis. One last thing to compare and just make sure we understand. The domain represents all of the x values included in the function. In this situation, for Bob's Burgers, we were ordering either 1, 2, or 3 burgers. So that means the domain, the input values, as you can see right here. Your input values would be 1, 2, and 3. So that will be your domain. The same idea goes for the range. It's just your output values, the result you get when you buy 1, 2, or 3 burgers. Well, you're spending $5, $10, or $15, so that would be the range, 5, 10, 15. The last thing that we're going to talk about is a couple vocabulary words, and it just represents another type of situation you could be in with a function, where you have either a discrete or continuous function. Here's what those words basically mean. A discrete function is one where the input values are countable. Typically, they will be whole numbers, things that you can count individually. For example, when you go and see a movie and you purchase a movie ticket, you can only buy movie tickets in increments of 1, 2, 3, 4, etc. You can't buy half of a movie ticket. Same with students riding a bus. A student is a person. You count people. You can't have half of the person. You can't have 1/3 of the person. You just have individual students that are counted by 1, 2, 3, 4, 5, etc. And then because it's the soccer season right now, the goals scored per game, if you score a goal, you are receiving 1 point for that goal, and you're not getting half of a goal. If the ball enters the back of the net, well then you are scoring the point. You are not getting a fraction of a point. A discrete function is one where the input values are countable individual units. A continuous function is one where the domain might include decimal or fractional values. So for example, if you're at the grocery store and you're purchasing bananas, or any fruit for that matter, you might be paying per pound. So you might not exactly pick up a banana that is 1 pound. It might be a little more than 1 pound. It might be 1.1 pounds. It might be 1.2 pounds. When you purchase things that are measured by weight, you are now involving decimals and individual increments that aren't just whole numbers. Likewise, gasoline used per bus. As any vehicle drives around, the gas that's in that vehicle is not just magically disappearing 1 gallon at a time. It trickles away piece by piece. You lose a little bit of gas as you drive, so it's measured in ounces, in gallons. And then lastly, if you are playing any sporting event and you are drinking, let's say, Gatorade on the sidelines, well, your measurement is not going to be an entire liter of Gatorade at a time. You're going to be sipping a bottle throughout the game. You're going to be taking bits and pieces of it. So these would be continuous situations, ones where decimals and fractions, smaller increments, can be included. A discrete situation is one where you are counting things as whole numbers, like movie tickets, like people riding a bus. The continuation of this lesson that we did today in class. Basically, let's bring the screen back up. There we go. So sometimes a function is not actually a one-to-one function and therefore is not a function at all. So sometimes we have equations, we have expressions that we think might be functions, but in reality they're actually not functions, and we're going to look at that right now. Here's the primary way to tell when a function is not actually a function. If the same domain value repeats itself, but is paired with a different range value, then the function is not a function. If the same domain is paired with different range values, then the function is not a function. So just to recap what was talked about up above, the domain value, that's all of your x values. The range value is all of your y values. So if you look at this first example right here, written in blue, take a moment and look and try to figure out which ordered pairs are showing you that this is not a function. The same domain is paired with a different range value that's not a function. If you were looking right here at 2, 3 and 2, 6, well then you are correct, because it's not a function since 2 is paired with 3 and also 6. The same domain value, being 2, is paired with 2 different range values, just like it says right here. To go back to the mapping diagram and graph work that we looked at just before, this is what that situation would look like for a mapping diagram. As you can see right here, the number 2 is pointing to both 3 and 5. The same domain value is going to 2 different range values. And then right over here on the graph, you can see that 2, 3 and 2, 6 are repeated values, or you're getting 2 dots that are on top of each other, like this vertical line is passing through both of them. This is not a function, this is not a function, this is not a function. The same domain value is pointing to 2 different range values. But the next thing we're going to look at is a little bit more about this idea of how you look at a function on a graph. Notice, this is not a function, and we have a pretty much vertical line. I drew it slightly crooked, but a vertical line passing through both of these points. This is actually a concept called the vertical line test. The vertical line test basically means if a vertical line can be drawn through at least 2 points on a graph, then that function is not a function, or then that graph is not a function. Let me show you what I mean with these examples right here. If we look right here at this first graph, it's shaped like a U. If I take a vertical line and I place it right here, for instance, you can see that it is only passing through one spot on this graph. Likewise, if I move the line to right here, it's still only passing through the graph at one location. The graph being the green line, by the way, if that wasn't obvious. If we look at the second function, though, it's a circle. The vertical line is passing through the circle at 2 different locations. If a vertical line can be drawn through at least 2 points on the graph, then that graph is not a function. This is a function. This one is not a function. The vertical line is intersecting the green graph in 2 different locations. The last example, if the vertical line is right here, here, or here, anywhere along this line, this arrow means it goes on forever, by the way. The arrowhead is not part of the function, it just represents it going on forever. This vertical line is only intersecting the graph at one point. So basically, the U shape is a function. The vertical line only passed through at one location. The circle is not a function. The vertical line intersected it at two different locations. And then this last graph is a function because there was no location to put the vertical line where it would only intersect, one time. Now, here's a little analogy that might help you understand when something is or is not a function. The main rule is right up here at the top. If you understand this, then you're all set. And maybe that analogy wouldn't be something you need, but I'm going to go over it regardless. If the same domain value is paired with a different range value, then the function is not a function. Let's take a look at the phone analogy. And when I say phone, I'm talking about a landline phone, not a cell phone. Cell phones can kind of do things now that might break the flow of this analogy. So just think about the fact that a phone, maybe 20 years ago, would only be a landline phone plugged directly into the wall. That's kind of the idea we're talking about here with the phone. So here's an example of how this analogy would show you what is a function. Your domain value will be telephone numbers, and the range value would be the people you would get when you dial those numbers. One phone number connects to only one person. That's how a landline works. You have one number, it connects you to one household or one person, however you want to look at it. So you have your own number, your mom has a number, your dad has a number. You can think of it, I mean, you could put anybody here in this range. It's just the point of one phone number, one person. But if you look at it from this perspective, if you had a phone number that was connecting you to two different people, well then that really wouldn't be very useful. Typically when you dial somebody's number, you're getting just that person. You're not possibly getting two different people. That's not a working phone. One phone number, one person. The same phone number won't connect to two different people. So this is showing you how it would not be a function. The same domain value is pointing to two different range values. The last thing that we're going to briefly look at, and this will be explained more in class, the composition of functions. Here's the basic idea. If x is considered the input value, then f of x is another way to express the output. This might be new for you, this terminology. This does not say f times x. This says f of x. And here's what it means. It's referring to the output value. And if you remember from up above, the input value is x, but your output value is the variable y. Draw that a little bit better. There we go. It's the variable y. So notice right here, we have the function 3x minus 1, and it says y equals 3x minus 1. This means the exact same thing as saying f of x equals 3x minus 1. Let's say we had a domain of 0, 1, and 2. Well, if you plug in 0 to this function by replacing x with 0, as you can see right here, and then you continue evaluating it, 3 times 0 is 0, 0 minus 1 is negative 1, you get a y value of negative 1. But look over here. It's essentially the same idea. You're just using function notation. This does not say f times x. It says f of x. And it means your output value, the y value. They mean the same thing. Just notice, 0 from the domain is being replaced by x, but it's happening in two different locations. So over here, we only had to replace one x with a 0, and we got negative 1 at the end. And over here, when we replace both of these x's with zeros, you're still getting the same answer. This is just saying, f of 0 equals 3 times 0 minus 1, or 0 minus 1, which is negative 1. Basically, this sort of means, if you were to say it with a few more words, the function, when you plug in 0, is going to equal 3 times 0 minus 1. Up here, the function, when you plug in some value for x, is going to be computed by doing 3 times x minus 1. That is a very big idea to really understand. Make sure you get what function notation is referring to. If you have to pause and rewind the video, please do so. It just means the output value, the y value. Just to do one more domain, we have a domain value of 1 since we just evaluated 0. Here's the work for plugging in 1. Over here on the left, we just replace the x value with 1. But over here, we have to write out f of 1 equals 3 times 1 minus 1. And you still do the computing the exact same way. You're going to get the same answer on both sides because, again, it just means the y value. F of 1 is going to equal 3 minus 1. F of 1 equals 2. The function, when you plug in 1, gives you an output of 2, or y equals 2. I hope this video has been helpful. Please ask any questions during class, and I'll see you next time.